Okay, so let's do another indefinite integral, okay, or definite integral. So let's, again, we're going to use the fundamental theorem of calculus part 2. So now what I'm going to do is I'm going to write this. I need to find the antiderivative of this here. So in order to do that, I'm going to split it up first, then deal with this. So I'm going to write my integral as 1 to 9, so the integral sign, limits of integration 1 to 9. And I'm going to write this as x over the square root of x minus 1 over the square root of x dx, which is then going to be equal to the limits of integration from 1 to 9. And this is going to equal the square root of x, right? Because this is x, and this is x to the 1/2, so I'm just going to get x to the 1/2. Minus well, 1 over x to the 1/2. So actually this is going to just be x to the 1/2 minus x to the negative 1/2 dx. And so now I know the integral of both of these, and I can do it term by term. This is a continuous function from 1 to 9, no issues. So now I can set this equal to, what's the integral of this? What's the antiderivative of this? Well, you increase the power by 1, so that's going to make 3/3 or 3/2, and then you divide by the new power. So, or in this case, you're going to multiply by the reciprocal, and so you get 2/3 x to the 3/2 minus, again, you're going to add 1, so you're going to go from a negative 1/2 to a positive 1/2, so this is going to be minus 2x to the 1/2 power, and this is going to be evaluated at the limits of integration 1 to 9, okay? So notice I did not put the constant of integration in this time, because they always cancel out. So now all I'm going to do is set this up as this evaluated at 9 minus this evaluated at 1. So this is going to be 2/3 9 to the 3/2 minus 2 times 9 to the 1/2 minus the same quantity evaluated at 1, which is going to be 2/3 1 to the 3/2 minus 2 times 1 to the 1/2 power, and now it's just arithmetic now. So now I'm just going to simplify this. This is going to become 2/3. This is going to be 3 cubed, which is 27, minus 3 times 2, which is 6. Now I'm going to subtract this whole thing. So this is going to be minus, well, this is just going to be 1. So this is going to be minus 2/3 plus 2. Okay. Now this is going to give me 54/3 minus 2/3, right here, minus now 6 is the same as 18/3 plus 6/3. Okay, and now what do I get? 54, 52, 42, 34, 40. So I get 40/3. And that's the answer. So in other words, by the way, what we just found out is the area under this curve from 1 to 9. So the fundamental theorem of calculus has really helped us find areas under the curves of some complicated looking functions. So we've looked at squares, trapezoids, triangles, and we were able to use formulas for those, but now we don't have to use formulas. As long as you know how to get the antiderivative, we can use the fundamental theorem of calculus part 2 and do it all day long. Okay? Have a great day.